Okay, so let's look at some examples of graphing absolute value functions that have been translated. So according to the function f of x equals the absolute value of x minus h plus k, h controls going left or translating to the right. K, the number outside the absolute value, controls translating up or translating down. And to get the vertex of the absolute value function, we're going to always make it h comma k. So the vertex is h comma k. But if we look at the equation closely, the negative sign in front of h means that for the vertex, we're going to use the opposite of h in the equation. And then the plus sign in k tells us that we should be using the actual k value from the equation. So if I look at number 10, if I look at h is, it says -4, but that means my x coordinate of the vertex is going to be +4. And for k, it says +2, so that means my y coordinate of the vertex is going to be +2. So I do opposite of h, comma k. So I do opposite of what I see in the equation, but I keep the k value the same. So I'm going to go over 1, 2, 3, 4 to the right and up 1, 2 to plot my vertex. And since absolute value functions are two linear functions put together, I can essentially use slope to plot the remaining points. So I'm going to go up 1 over 1 on the right-hand side, and I'm going to go up 1 over 1 on the left-hand side to give the two different linear functions. And so that gives me my graph. For this next one, h is going to be 3. So I do opposite of what I see in the equation inside the absolute value for h, and then I do exactly what I see in the equation for k. So my vertex is going to be +3, so opposite of what I see inside the absolute value, comma -5, exactly what I see outside. So I'm going to go 1, 2, 3 to the right, 1, 2, 3, 4, 5 down. And again, once I've plotted my vertex, I can go up 1 over 1 in each direction to plot the arms of the absolute value, or like the two linear sides of it. And then this last one, h is going to be -7 because I see +7 in the equation. So I do opposite of that. K is going to be -1. You always do exactly what you see outside the absolute value. So this tells me that the graph went left 7 and down 1. So I'm going to go 1, 2, 3, 4, 5, 6, 7, down 1. And I'm going to go up 1 over 1 in each direction to plot the two sides of the graph. And so that's going to be the graph right there. Okay, so if I have to write the equation, I want to start off by identifying where the vertex is. So the vertex is 5, comma 1. So h and k I get from the vertex. And so in my equation, I do opposite of h, so -5 to show that 5 is the coordinate of the vertex. And then I do k on the outside, +1 to show k is 1. So it's opposite of h, regular k. For this one, I went 3 left and 3 down. So the vertex is -3, -3. That's h and k. So inside the absolute value, I do opposite of h, +3. Outside the absolute value, I do k, -3. Here, my vertex is -2, 3. So inside the absolute value, opposite of h, outside the absolute value is k. And for this one, it's 4, -5. So again, inside the absolute value is opposite of h. Oops, that's a parenthesis. Outside is k. So this last section here, we need to do the domain and range. So the good part is domain is always all real numbers because these graphs get infinitely wide. All x values will be represented. For the range, we're going to use the value of k. So -7 is the value of k here. So my range are that the y values have to be greater than or equal to -7. Because if I think about it, -7 is going to be the lowest y value on this graph. I'm going to have to go down 7. Everything else is going to open up above it. So all the y values are going to be bigger. Here, the k value is 0. So my range is going to be y is greater than or equal to 0. And then for this last one, my k value is -1. So my range is going to be y is greater than or equal to -1. For now, the symbol is going to be greater than or equal to because for now, the shape of the absolute value is opening upwards. That'll change to a less than once we get graphs that instead of opening upwards, face downwards, which we'll see next time.